further ado, I'm super excited about the next speaker. And I've got a little bit of an anecdote here anyway. I remember when I was trying to find my feet in the plant-based protein world, I was speaking to many people, trying to get the right network going, but also understanding the market. And I remember this one conversation I had who said, you must speak to Denis of Improve. If you really want to understand what's going on in the market, he's the person that can really outline it to you. He's already done lots of conferences. He's spoken at a lot of areas, and he's not just very friendly, but he's super insightful. So I'm so pleased he's our first speaker today. With that, I'm going to kick it over to Denis, who's the general manager at Improve, the first open European platform for research and development for fully dedicated to the valorization of proteins. Denis, very good to see you. I will kick it over to you from here.
Thank you very much, Marcel, for this very kind introduction. And today I will try to present some market information. You know, Improve, I'm the CEO of Improve, and Improve is an R&D center located in France, 1 hour north of Paris. We have 27 people in the team, and we serve more than 450 customers worldwide. So this is why we have a lot of information. Of course, today I will not violate any confidentiality agreement, but I will give you the big picture of what we observe inside Improve in relation of these customers. So a few figures to summarize important matter. So first, the raw material. Every year, basically, you have 10 billion tons of agro material produced, and 74% of it is given to feed for animal conversion. Animals are transforming plant-based protein into animal-based protein. 18% of this material is going to the food chain, and less than 10% is used for energy or for material. And this is a very uneven distribution and use, because you can see that only 18% of the world population can afford to pay for 60 grams of animal-based protein per day. So these 10 billion tons contain 555 million tons of plant-based protein. So if I do a kind of mass balance of this plant-based protein in the world, you can see that these 555 million tons distribute into the feed chain. 440 million are going to this animal conversion in order to produce only, I would say, 89 million tons of animal-based protein. So the global conversion yield is around 20%. And you see on the right of the screen that depending of which animal or which production, there can be some differences. But the losses are between 60 and 90%, depending which animal and which production you consider. Only 115 million tons of protein are going straight to the food chain. And you see the very small bar, the 2.7, it's the million tons of protein ingredients, so which are concentrate or isolate. And that's the main topic of today, I think. So if we want to do something to improve the situation, we have to see how we can deal with this red bar, either going on the right, meaning producing more plant-based protein to increase the offer and to sustain the growing population, or to reduce a little bit the use and the conversion through animals, because every time you send 1 ton of protein to animals, basically you lose 0.8 ton of protein. So to summarize, protein ingredient will not save the world. It will just make our life, or Occidental life, easier, because of course it's not gaining any ton going through ingredients. Now, if we go to the main contributors of this protein, plant-based protein production, 2/3 can be explained between the cereal, the oilseed, and the pulses. And you see that by far, cereals are the #1 producers of plant-based protein in the world. And the second is the soy. And far behind, you see pulses. And pulses are very popular right now, because we speak about pea, chickpea, fava bean, a lot of newcomers. But you see that they are contributing very, very little to this big picture. When you select your plant-based protein, it's also important to see how this plant source can impact your environment. And you see that I put here some info linked to the tonnage of protein produced per year and per hectare. And I also put different colors. The colors are linked to the plant fixing nitrogen for the green one, and the orange, the one needing some fertilizers. And there is a good indication to be followed is what we call the symbiotic nitrogen. This symbiotic nitrogen is the nitrogen coming from the atmosphere fixed by a plant, and that you can find in your food diet. After Second World War, this symbiotic nitrogen was close to 100, and now in Occidental countries, it's less than 5. So it's a perfect indication that the way we grow plants today is not sustainable, and we need to rebalance a little bit, not to go back to 100%, but at least to be largely above 50%. This picture is showing where are the big flows of protein all over the world. And you see that Asia is by far the #1 producer, but it's also a biggest consumer, meaning that they need to import a lot of protein. By chance, South America is producing a lot and not consuming that much. So the delta can go to Europe and Asia. So you see globally the picture, and you will see who are the players importing and exporting protein. When you look at the market, we made a study 2 years ago in Improve, and we identified more than 100 different commercial products available, coming from 35 different raw materials, produced by 138 different producers, or distributed by 66 different distributors. And these products were in the form of flour or concentrate, isolate, or hydrolysates. And some were claiming to be functional, only 40% of them. Some were claiming to be nutritional, only 29% of them. Some were claiming to have a positive impact on the organoleptic profile of the final application, only 30%. Few were GMO-free and few were organic, just to see how the offer was very diverse. Now, if we look at the demand, the big challenge for a consumer is how many options do we have in front of us, and why to choose this one? Is it healthy, hedonic, durable, ethical, economical? So it's a perfect way to become totally crazy. So if we look in the past human history, by design, humans are omnivorous hunter-gatherer. So they were eating a little bit of plant-based protein, and they were hunting and farming some animals. And sometimes they were growing some microorganism, and it was a good way to combine all these protein sources. Now we see, for example, the vegan. It's perfectly possible to become vegan, but it's a quite complex diet. And there are some challenges around the iron and B12 vitamins. So you need to be quite aware and well informed to be a good vegan without any risk for your health. The classical animal conversion. So you have the simple one going through one step, as we can do historically. We see more and more people working on insect, but insect going to fish, fish feed, and then you eat the fish. So you have a double conversion system, which is a double protein losses. At the end, you see that your protein efficiency can be quite reduced. So the challenge is yield, cost, and sustainability. Another interesting way to produce protein is biotechnology. So you produce, the carbon sources will be coming from carbohydrates, sometimes from fats, and the nitrogen sources will be mineral and coming most of the time from ammonia. And then you can grow bacteria, yeast, fungi, and you can go even in the more sophisticated way, produce cells, animal cells, where you need some addition of animal-based extract. So This biotechnology is a good way to produce alternative proteins in addition of the plant-based one, but the main challenge will be related to the cost of this production. And today, the cost is extremely different. If we compare amino acid produced by fermentation of bacteria or cultured milk, it's a totally different price in euro per kilogram. When we speak about protein, there are 4 ways or 4 dimensions to explain the quality of your product. It can be nutritional, functional, organoleptic, and bioactive. So for the nutritional value, most of the time we speak about the essential amino acid balance, and we know that plant-based are not always totally balanced, but we know also that combining different plants together will bring you a perfectly suitable amino acid profile. The second dimension is around the speed of digestion. You have some slow protein, fast protein. The fast protein are well adapted when you want to grow muscle. So when you are young, when you do sport, when you are growing animals. And the slow protein is well adapted when you want to make some weight management. So it's a good way to prolongate the satiatonergic effect of the protein. And more we see formulators willing to play with the messenger function of specific amino acid, like for example, the leucine, which is stimulating the protein anabolism, or the arginine, which is playing a role in the blood pressure regulation. Functional properties, if I summarize this on a funny way, if you eat a crude egg plus dark chocolate, you will have the same nutritional value than chocolate mousse, but not the same pleasure. So in fact, functional properties will help, will not impact the digestibility, but will help the food processor to diversify the offer. It will also enhance the consumer pleasure, and it will allow the ingredient producer to sell at a higher price and to make a better margin. Organoleptic profile, plant-based protein are very often associated with off notes like astringency, bitterness, beaniness, etc. But there are strategies to deal with these off notes by a very nice raw material selection. You can also work with your different varieties. You can, during the processing, you can prevent some off notes developments. For example, a good deoling, some enzyme desactivation, a good microbial control. You can eliminate during the post-processing of your production. And you can, for example, if you are not successfully achieving step 1, 2, or 3, you can play with masking or formulation. The 4th dimension is related to the bioactive properties. So it's much more limited in tonnage, but it's quite interesting because it's a way to develop properties having an impact on your metabolic syndrome, on your cardiovascular system, nervous system, digestive system. Some peptides or some protein can have some antimicrobial effects, some antioxidant or anti-radicals effects. And what is also interesting is to see, so these applications are mainly in the cosmetic or the food supplement markets. We see more and more people working also on crop protection using peptides or using proteins. And that's also in R&D a very nice area for investigation. Now, having all this in mind, it's also interesting to know what price we can explain, justify, depending of these different protein. Of course, Mintech Global is expert in doing this kind of presentation. But if we want to summarize all the detailed information that Marcel and his team are able to share with you, I built this matrix explaining that depending on the protein content and the protein properties, you can justify the evolution of the price in euro per kilogram. For example, on the bottom line, if your protein is insoluble and low in concentration, then your protein price will be extremely cheap, 0.2, 0.3 euro per kilogram. For example, the corn wheat gluten can be sold at 0.8 euro per kilogram. The vital wheat gluten, a little bit higher in concentration, around 1.2 euro per kilogram. If you solubilize this vital wheat gluten with proteases, you can almost double the price. Then you can reach some other application. Most of the protein concentrate coming from pulses are in the range from 2 to 3 euro per kilogram. If you go to the quality of isolates, then you are moving from 3 to 8, sometimes 10 euro per kilogram. The top right corner is for bioactive products, and then you can be above 30 or sometimes 1,000 euro per kilogram. Just to say that depending where you are on this matrix, you can claim for specific reason a specific price. And when your process is moving one product from one area to another, you have always to pay attention to be totally relevant and to make sure that your economical balance will be well adapted to your market. Another comment is, of course, this pricing in terms of production costs will be highly related to the size of your production facility. I took here the example of the wet processing to produce isolates. And we can say basically that if you want to build an isolate production plant, below 10,000 tons of protein produced per year, you will have a very difficult time to achieve a price which will be lower than 5.5 euro per kilogram, which is the average market price, for example, for pea protein today in Europe. So pay attention to the size, and this is why we say that globally, this wet extraction process is extremely expensive. A plant producing 10,000 tons of protein per year will cost basically 100 million euros. So only few companies worldwide can afford to put this money on the table. And this is why also we comment on the fact that a dry process will be much more affordable because the investment cost will be between 10 to 20 times cheaper in terms of investment. One important comment to be made before we close this session is it's not because we speak about pea, faba bean, or lentil protein that it's always the same. We took the example last year in Improve. We took 20 pea samples from the market and we made different functional properties assessment. I here put only the foaming, but we were having the same result for other protein properties. You see that out of these 20 pea proteins, only 2 were good performers in terms of foaming, 6 were terrible, and the rest was just average. And they were all pea, so it's not because they are pea that you can say it's a good or it's a bad protein. It's very often linked to the pea itself as a raw material, the area where it's grown, but mainly for the process. So it's very important for you when you want to select your raw material to pay attention to the big variability of these ingredients. Now, if we look at the future, Market made a very interesting study showing that soy protein is today the #1 player in the market and will be in the projection in 2025, will still be the #1. Wheat is the #2, but with a more limited growth. Pea will almost double. It's #3. It will almost double in the coming 5 years. And you see other sources that are extremely limited. They are very promising sources, but it will come maybe in the future, which will be after 2025. If I want to conclude now my presentation, the take-home message are that first, this alternative protein market is extremely rapidly growing. There are multiple sources available, but they are not all the same potential. So you have, based on what I said, to really be careful when you want to select in your application the right sources. And it's absolutely necessary if you want to develop a sustainable agriculture to diversify the crop rotation in order to enlarge. You know, in Western Europe right now, an average crop rotation is between 3 to 4 years. And it should be minimum 8 to 10 years if we want to have a really sustainable agriculture. So this needs to imply the addition of newcomers from the breeding to the processing, but also from a consumer standpoint, because if nobody is consuming the diversified crop, there is no chance to develop this. So I am now at the end of this presentation. I will be more than happy to answer all your questions.
Thank you so much, Denis. That was very insightful, as we all expected. Again, reminder for everyone, we've already got some questions in the Q&A box on our end, but at the bottom you can see the Q&A box. Feel free to ask any questions. Denis, let me kick off with a question on the soya, wheat, and pea that we've just looked at. And obviously, you've shown us, I think it was just a couple of slides ago, that pea will double over the next 5 years, but also that actually wheat is one of the largest pea proteins in use. How come there isn't so much discussion about the wheat protein? The focus seems to be on pea. And do you think going another 5 years forward into 2030 potentially that pea will overtake wheat? And I mean, that's probably something we can also ask our next speaker from Roquette afterwards.
So pea right now is around, in terms of protein, it's around 120,000 tons of protein produced per year in ingredient form, and the wheat is close to 1 million. So the gap is still very big, and the wheat is basically the side stream of the starch, the wheat starch industry. So we don't expect a big growth for wheat because we don't expect a big growth for wheat starch demand. It's not at all the same in pea because the main product of the pea process is the protein, and there is a strong demand right now. This is why we expect a double production in 5 years, and I'm sure that it will continue like that. I'm not sure that pea will be that big compared to wheat, but it will grow nicely during the coming years.
Okay, perfect. There's actually been a couple of questions on that coming up as we were talking on this. Another question here, which probably I should have made clearer in my introduction initially. All of the sessions will be available afterwards. So by probably tomorrow or Monday, if you log back into the platform, you can re-listen to all of these questions. So good question. We've got another question here, Denis. It comes from one of the participants asking, how do companies go about dealing with the variability and functionality even of the same protein source? And I think it's relating back to your slide on pea protein forming properties.
So the main thing is to understand where is this variability coming from. And we make a lot of studies for our customers in Improve to understand the variability coming from the raw material. There are some, but it's not extremely big. We see breeders putting on the market extremely different and extremely interesting new varieties of, for example, of pea right now. Of course, there will be a strong impact on the protein quality. But today, the big part of this variability is coming from the process. And depending the process, you know, I'm going back to the pea process. The process in China is different than the process in Roquette, in Cosucra, in North America. And the fact is coming from the maturity of these processes. If I compare, for example, the starch industry from corn, the process is mature since decades. The wheat starch process is now arriving to maturity, and the pea starch process is just at the beginning of the story. This is why you see so diversified processes, and this is why you see a big fluctuation in these functional properties.
Fascinating, thank you. We've got a question on isolates and concentrates. I think we're going back to the point that isolates have a very high concentration of protein versus concentrates. I think it comes back to something you said earlier about, you know, being young, being old, being an athlete, not being an athlete. And the question goes on to ask, who will be the winner? Will it be isolates? Will it be concentrates? What are your thoughts on this?
I think they will be complementary always because isolate is high in purity. You can better control the functional properties. You can better control off notes and anti-nutritional factors in isolates. But they will be still very high in price compared to the concentrate. The concentrate, they are low processed products, so they will attract the attention. They will be low in price, but they will still be having some anti-nutritional factors, some off notes, which can be managed, but not totally. So there will be a combination, and sometimes for application purpose, sometimes for cost reasons. But I think application will always try to combine as much as they can these two options.
Okay, thank you. Another question we've got from participants here is, what is the penetration of plant-based proteins across the meat analog space, and how are you projecting the growth of these proteins across the meat analog?
So I think the Beyond Meat story is a perfect example. The combination with rocket isolate is giving you the direction. In Improve, we see a lot of companies worldwide just willing to duplicate this success story. So the view I have is a lot of companies will try to develop a new isolate from pea, but maybe from other sources. We see the faba bean arriving on the market, and we see few production sites starting up their facility, either right now or in the coming years. So there will be, I think, a diversified offer of ingredient in order to fulfill this demand coming from meat analogs.
It's an interesting point that when you mentioned fava bean and potentially also then moving on into the organic space, right? It's just another cost point. Yeah, and I think from conversation we've had prior to this, fava beans seem to be a little bit more expensive than your regular pea proteins. How do you think that would play out?
In fact, a part of the cost is coming from the raw material price, and faba bean is a little bit more expensive than pea, but there are more proteins in faba bean than in pea, at least the regular pea of today. So I think at the end, we shouldn't be so different in terms of pricing in the faba bean isolate. But you know, when something is new, you have always an interest to try to maximize your price. So then it's a marketing strategy. But from a scientific standpoint, from an industrial standpoint, I don't see a lot of reasons to justify a big gap in price between pea and faba bean.
Okay, and organic, do you think organic can start to play into the whole plant-based protein thing, or do you think that's again something
No,
that's
no,
quite some years away?
it's already playing a small part, but you know, organic is globally playing a small part. It's a growing part, but it's still a small part. The main challenge with the organic will be the price and the global productivity, because depending where you are, but when you grow organic, usually your yield is between minus 30 or minus 50% compared to regular agriculture. So worldwide, you can't afford to just do minus 30% or minus 50% of agro production. So it's, I think, always limited. And I hope that organic will move into something which will be more sustainable, having all the big benefits from the environment, but also having the productivity which is necessary with this growing population.
Okay, thank you. Let's again, we keep getting questions coming through, so guys, keep them coming in. We're always happy to answer them, and if we can't get through them today, we'll answer them afterwards. Got a question on different regions of the world and plant-based proteins. And I think the question goes as, do you see differences in the plant-based protein development in the different regions of the world? I guess that's relating to North America, European, and in particular China, right? We've got quite a price discount in China in particular.
In fact, what we can see today is, for example, in China, the Chinese are importing Canadian pea. They are making the ingredient production. Ingredient can be protein and starch, and they are re-exporting proteins to North America. This model, I think, is not really what I can imagine for the future. And I think that locally, depending where you are, they will grow different plants from which we will produce protein extract to be used hopefully locally in order to minimize the carbon footprint of this production. But today it's funny to see that products are still moving a lot. The higher will be the energy price, the more impact you will see on the traveling and the transportation of this material. And I think it will contribute to reduce this, and then you will be more locally grown and locally fractionated.
Okay, I'm smiling a bit because a lot of questions that we keep getting in at the moment are about asking you to look into that crystal ball and what's the future going to be like. One is you've just mentioned that you, at least in the short term, can't see the fava bean and the pea being priced competitively. Now, this actually goes on to asking pea versus soya. I think from we see my lens where I look at current market dynamics, they are starting to come closer together. I think you can see conversion there. But can you see them kind of being at a similar price? And if so, maybe when can you expect that to happen?
Soya price are quite low because two things: the quantity of protein in the soy seed, which is high, and the value you can extract from the oil. So the starch price today has some difficult time to achieve the same revenue generated by the soy coming from the oil. So for these two reasons, I think soy will still be and will be in future in a very good cost competitive position compared to pea or even faba bean.
Okay, thank you. We are coming towards the end of the session. There's still a few questions coming through. Let's look at this one. How do you expect the pea isolate market to evolve in the coming 5 years? And I think it's looking at pea isolates in particular, maybe shedding light into the competitive regions, looking at North America, looking at Europe, and anything potentially out of China even?
Yeah, in fact, again, you have to look where are the main quantities of pea produced. So North America, Canada. We see also more and more Russian players willing to produce pea isolate. And it's interesting because they are producing at extremely cheap price and they are quite well positioned in terms of energy. So they are between China and Europe. So they are quite well positioned if they want to export. So I think these kind of countries will play a big role in future. Again, if China still need to import all these pea to process them, I don't think that it's a big future.
Okay, understood. I'm going to do one more question. We've got a lot more outstanding, guys. We'll get back to you afterwards. We've obviously got access to the questions, and Denis and I will put our heads together and make sure we can reply to you. The question comes or goes as: is it possible to keep the same level of protein content with every batch, not depending on the external conditions in soy concentrate and soy texture?
Or when you do the protein ingredient production, I think you can manage quite well the protein concentration at the end because you can play with the parameters of your process. So yes, I think it's quite easy. And when you look at the market, the variability is not coming from the protein content. The variability is coming from the protein functional properties.
Okay, perfect. Denis, I'll leave it there. Thank you so much for obviously all of that insight and helping us with this. Now, we've mentioned Roquette a lot actually during our Q&A session.